Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing Layer 2 security and loop prevention. In this lesson, we'll be covering the configuration of STP and RSTP on Junos devices. In the previous two lessons, we've taken a deep dive into the theory, operations, and technical details of STP and RSTP. In this lesson, though, we'll be going over how to configure these protocols on Junos devices and how to monitor the protocol state once it's deployed. So let's get started. The original spanning tree protocol, 802.1d, is configured under the Edit Protocols RSTP configuration hierarchy. As we saw in a previous lesson, RSTP is backwards compatible with STP. This is mostly possible because the BPDU frame format is identical between the protocols. The protocol version and a few other fields in the frame are just populated with values used for STP instead of RSTP, so the participating switches know to follow the process in STP instead of RSTP. The default configuration prefers Rapid Spanning Tree Protocol, since it is generally the better of the two options. However, Junos devices are compatible with standard spanning tree protocol. To use 802.1d on Junos, we must configure the force version STP command, as shown here. If all configurations are left at their defaults and not explicitly changed, they will default to these values shown here, with the exception of the interfaces, of course. If you do not wish to change any of the default timer values, then you do not need to specify any of these configuration lines. If you do wish to change any of them, these values are in seconds. I primarily wouldn't expect to see 802.1d in the wild, except in cases of there being significantly outdated or no longer supported hardware. In these cases, you may find that you must run 802.1d if your network conditions dictate. Let's see now how we configure RSTP. You may have guessed that it's a rather similar configuration. To configure RSTP, we simply omit the force version command. Since we're working with RSTP, we have the additional port roles here that may be configured, like point-to-point. Otherwise, the configuration is identical. To enable STP or RSTP on a port, simply configure the port like here, under the Edit Protocols RSTP configuration hierarchy. It's possible to configure Interface All in Junos to enable STP or RSTP on all interfaces by default, which is generally good practice. In this circumstance, we'd simply configure the Edge command to set our edge interfaces where end hosts connect. Except for the Enhanced Layer 2 software, or ELS, version of Junos, where the Interface All command is not a configuration option. So, configuring STP and RSTP is pretty straightforward. Now, let's take a look at what commands we can use to monitor a spanning tree environment. In this slide and the next few slides, we'll show the configuration that was applied in the upper right, like here. This is the configuration that was used when this output was generated. In our configuration, we've only enabled spanning tree on a single interface, GE001, and we've forced the switch to operate using 802.1d protocol standards instead of 802.1w, using the force version STP command. Here, we can take a look at the local switch's STP or RSTP process using the show spanning tree bridge command. In the resulting command output, the enabled protocol will state whether we're running STP or RSTP. As we can see, this output shows we're running STP, which correlates with the configuration that was applied. We can also see the bridge ID of the switch that this local device believes is the root bridge in the STP topology. Below, we have the local parameters section, and we have the local switch's configured bid as well. These two fields match, so this switch currently believes itself to be the root bridge. An important line of this output in troubleshooting network issues is the number of topology changes. This indicates the number of TCNs that the switch has received. If this number is incrementing, then there is some sort of inconsistency in the network. This can occur if a link is flapping, causing STP to reconverge often, or even if there's a loop in the network. In a stable network, we would not expect to see the topology changes value incrementing at all. So, now that we've reviewed the process of STP on this switch, let's take a look at the interface status. Using the command show spanning tree interface, we can see the current role, state, and properties of each interface on this switch that's participating in STP. In the configuration here, we only have a single interface configured, which explains why there's only a single interface shown in the output. From the right, this command output gives us the port role of each participating interface. In STP, this will show a value indicating the interface is a designated port, root port, or blocked port, as these are the only three port roles that exist in STP. In the next left column, we have the port state for each participating interface. For STP, this will display one of 5 values: forwarding, learning, listening, blocking, and disabled are the 5 possible port states in STP. In the next column left, we have the port cost for the participating interface, which is dynamically set based on the port speed by default. The designated bridge ID displays the bid of the designated bridge on the segment that this interface is attached to. Similarly, the designated port ID is the port ID of the designated port on the segment this interface is attached. Recall that on a link or segment participating in STP, that will have a root port and a designated port, with the designated port belonging to the upstream switch, meaning the switch that is closer to the root bridge. The switch that owns the designated port is the designated bridge, unless that switch is the root bridge already. Finally, the far left column shows the port ID of each participating interface. The port ID is the local interface's port ID, and the interface is the local interface name that's participating in STP. This port ID could potentially match the designated port ID seen in the other column. So now that we've reviewed the operational command outputs for standard 802.1d STP, let's see how these outputs change when we configure the switch to operate in RSTP mode instead. Here, we see in the configuration that we're no longer forcing the use of STP, as the force version STP command is missing from the RSTP configuration hierarchy. As such, the enabled protocol field here shows RSTP, as is the default protocol version for modern Junos devices. Otherwise, this output is identical to what is seen when running STP. So let's see how the interface status output differs. First, this is the topology in use in this output example. We have 2 switches, switch 1 and switch 2. Switch 1 is the root bridge and connected to switch 2 by a single link. Therefore, we have one designated port and one root port, both in a forwarding state. In the configuration up here, we have the configuration for the switch 1 on top and switch 2 below. There's a single interface configured to participate in RSTP on each bridge. In the example outputs below, we see that the switch's GE001 is a designated port in the forwarding state, and switch 2's GE002 is a root port in the forwarding state. You may notice that this output as well is identical between STP and RSTP. However, RSTP will of course have different port roles and port states. The RSTP ports may assume one of four roles, which are root, designated, alternate, and backup. Finally, the port may be transitioned to one of four states as well, which are disabled, discarding, learning, and forwarding. Thank you for working with me through how to configure STP and RSTP on Junos devices, as well as how to monitor the state of the spanning tree process and participating interfaces. I hope that this has been informative for you, and I would like to thank you for viewing.